Hello everyone, welcome to Benji Physics. In our today's video, we are going to talk about centripetal force and centripetal acceleration. But first, let me remind you, if you didn't watch my previous videos about angular displacement and angular velocity, then kindly go watch them because this tutorial directly linked to them. Anyhow, in this video, you and I will answer two questions. First, what is centripetal acceleration? Secondly, what is centripetal force and how to calculate it? Let us start with what is centripetal acceleration. Well, centripetal acceleration is a change of direction of the speed of the object that moves in a circular path. This change of direction of the motion of this object is caused by a force called centripetal force. Well, the word centripetal itself is derived from Latin, which is centripetal. Hopefully I pronounced that correctly. Anyhow, it means seeking the center. And this means every object that moves in a circular motion seeks the center of that circle. So, centripetal force is the force that makes an object moves in a circular path or around another object or around a center of a circle. Centripetal force, it could be a result of a physical connection like tension. For example here, the tension in the rope makes this ball spin around the center. Or another example, such as friction, it also causes centripetal force. For example, let us assume this rectangle here as a car. So as it moves straight along the path or the road, the friction between the tires and the road pushes the car inward or toward the center of the curve. So from all these examples, we notice that centripetal acceleration means a constantly change of direction of the motion of the object, although the speed is constant. Also, another thing that I should highlight here is that acceleration and centripetal force are perpendicular. Both of them are perpendicular or at a right angle to the path. Moving towards how to calculate centripetal acceleration, basically, centripetal acceleration could be calculated using the following formula. Centripetal acceleration equal linear velocity v squared over r as the radius of the circle. But this is not the only equation we can use to calculate centripetal acceleration. There is another two equations. Here is how we derive them. From the previous angular velocity video, we know that v as the linear velocity equal radius times the angular velocity or r times omega. So we can combine this equation with the centripetal acceleration equation to give us this second equation, which is a as acceleration or centripetal acceleration equal radius r multiplied by omega squared or r multiplied by omega squared. Omega squared here is the angular velocity. Or we can also use or rearrange the linear velocity equation again and combine it with the centripetal acceleration equation one more time to give us the third equation, which is a equal v multiplied by omega. Or acceleration is equal linear velocity multiplied by angular velocity. Let us take an example here to show how to calculate the centripetal acceleration. Our first example is about a ball tied to a rope that's rotating in a horizontal circle with a radius of 2 meters and an angular speed of 4 radians per second. Here to calculate it is centripetal acceleration if the radius was twice as large and the angular speed was also twice as fast. So here, as long as we have the radius and the angular speed omega, we can use the second equation, if you recall it, to find the centripetal acceleration, which is centripetal acceleration is equal radius times omega squared. Here, the main centripetal acceleration is equal radius times omega squared, and it is equal to 32 meters per second squared because the measurement unit of acceleration is meter per second squared. And regarding to twice the radius and angular speed means both the radius and omega times 2, and it is equal 4 and 8 radians per second respectively. So centripetal acceleration is equal to 256 meters per second squared. And regarding the centripetal force, well, it is defined as the resultant force towards the center of a circle required to keep a body in a uniform circular motion. And we calculate it using the following formula. F equal m times v squared over r, where F is the force measured in Newton and m is the mass measured in kilogram. And the other symbols we are already familiar with from the angular velocity video and angular displacement video. let us directly take an example to show how to calculate centripetal force. Our example here is about a stone of a mass of 8 kg that is tied to a spring of a length of 0.5 meter and rotating with a speed of 2.21 meter per second. So let us find the centripetal force that is resulted due to the tension on the spring. So as long as we have the mass and the length of the spring as the radius and also the speed, then we can plug in these values to the main formula. So here, F as the force equal m times v squared over the radius. And this is approximately equal to 78.01 newtons. Now we have come to an end for this part. One last thing, your likes and support will encourage me to do more content like this. So if you like my explanation, please hit like and subscribe to my YouTube channel so that you get to see the next upcoming videos. Thank you.